The theme today is industry expectations and engineering. We have with us today Professor TSK Murthy, Krishnamurthy Thurayur, or TSK as we all like to call him. He hails from the School of Engineering Sciences at MEC. He's an aerospace engineer who has been associated with India's space program for 15 years in an earlier tenure, after which he got into the corporate ambience, and then he joined MEC finally. He's with us today, and he's going to answer some questions that we have received from our audiences over the last 1 week to 10 days. And before we get on with the Q&A session, I would like to request Professor TSK to come on the stage and tell us a little bit about himself first. Thank you.
Good morning, boys and girls. It's a pleasure to be with all of you on this beautiful Saturday morning. The weather has been very kind, kind of cloudy, not so hot. But the topic that we are going to be talking about is going to make the air absolutely hot, because it's going to be engineering your own career. It's going to be a very, very interesting talk, I presume. Just to be giving you a kind of an idea as to what kind of person that you are talking to. My name is Dr. Krishnamurthy. I did my basic degree in science in mathematics, then went on to do my aeronautical engineering as my undergraduate course. Then I did my master's in aerospace engineering from Indian Institute of Science, and then joined Indian Space Research Organization and worked there for about 15 years. While working, I completed my PhD also from the Indian Institute of Science, but in the mechanical engineering department. I had the privilege of working with Abdul Kalam, Professor U.R. Rao, Dr. Raja Ramanna, Kasturi Rangan, and the stalwarts of the aerospace sector. After a decade and a half with the ISRO, I moved on to the exciting world of the information technology. In the information technology field, also I was really looking after only the engineering portion. That I did for another 15 to 20 years. I retired from one of the top IT companies of India as the vice president, and then I moved on to the academic field, and I have been teaching for the last 3 years, essentially in the area of structural engineering, if you may say so. That's in brief what I am. I'm willing to have an interesting discussion and try to answer many of the doubts or queries that you may have today.
Thank you, TSK. And without much ado, I'll move on to the very first question that I would like to ask you. It's a bit generic. What's your personal take on engineering today? Where do you think it's going?
There are a couple of areas in our life that we cannot dispense with. One of them is medicine, and the other is, of course, engineering. Without these two things, there won't be any progress. The society would become stagnant. As always, these two fields are very, very essential and are doing very well. And the engineering has been in kind of the rocket speed, if you will, in the last few years, or rather few decades, with the advent of computers, and now the kind of applications that we are looking at makes life a little more easy and much more exciting.
Okay, so what do you think are the emerging industry drivers that are dictating both the pace, the direction, and the intensity of the growth in engineering today?
See, every aspect is necessary. There is nothing called a watertight compartment in the areas of engineering, if you will. Uh, Unfortunately, in our country, we have created artificial compartments like mechanical engineering, electrical engineering, computer engineering, civil engineering, chemical engineering, etc., etc., etc. But if you look at a product or if you look at the industry, it's going to be multidisciplinary, if you will, because there is nothing that exists all by itself. For example, you think of a robo. What do you call a robo? Is it a mechanical element, or is it the intelligence built through the computers within this robo, or is it the electronics? It's a combination of all these things that make the robo do whatever it is supposed to be doing. And therefore, there is no specific field that is important. Engineering is all about a combination of many things, and be able to look at it in a holistic manner, if you will. That would help you to address the user requirements or the industry requirement. So I do not want to be taking sides saying that a particular department is more important than the other. Please don't get me wrong. The demand and supply are very, very different. Because of the many IT industries which are doing very well, if we tend to imagine that the IT field is the most important field, I don't want to say no, that's because the demand is more now. Even in engineering cycle, you would see that some years the mechanical engineering will be the most popular one. Some years it will be the electronics and communication. Some years it could be computers. Some year it could be civil. So this is all based on the supply and demand and what the societal needs are. But every engineering is important, and the society is going to be using all types of engineering to have a comfortable living for the human beings and make the life easier for people.
I agree with you, TSK, but I would still like to go back to one of those streams you mentioned. Not many parents and students seem to be very taken up with the idea of opting for civil engineering, and I think it's the most underrated of the courses at present. And everybody wants to go to computer science or electronics and electrical engineering. But from your personal perspective, how would you see the potential of growing by opting for civil engineering in today's era, modern day?
Okay. I'm sure there are students who are on the call who are also having a similar kind of opinion. I just want to make it a point here to this august audience that whether the aeronautical engineers or the automotive engineers, they use something called a finite element program for analyzing very, very complex structures. How many of you know that this branch of science was developed initially by the civil engineers? It is the civil engineers, Professor Argyris, Kelsey, Bates, Wilson, all these people have developed these tools and techniques, and now that is being used extensively in civil engineering, but much more extensively in the aerospace and automobile engineering. So if you tend to think that civil engineering is not a very exciting course, it is the kind of opinion that we have created, unfortunately, by ourselves. Civil engineering does not necessarily imply that you go and start building. Civil engineering definitely has that particular element of erection and commissioning, but then there is a large amount of design that goes on in order to create these kind of structures. Think of the airports, think of the shipyards, think of large factories that are in existence today. But for civil engineers, these wouldn't have existed, and the activities that go within these buildings wouldn't have been possible but for the help of civil engineers. So in order to think that civil engineering is not so very good is a misconception that many parents and therefore the students have that kind of opinion. But it is absolutely untrue. Absolutely untrue.
And so, do you envisage an increasing role of civil engineering in the emerging ethos of smart cities?
Uh, the thing is that if you really look at the kind of cities that we have in this country, they have been developed several decades ago, and some of them several centuries ago. And therefore, they were designed for certain types of loads and requirements of the yesteryears. But things are changing, and we've got to adapt our own cities to the extent that we can. We cannot dismantle some of the things that have existed for long, and therefore we have to have a workaround, and that becomes much more important. And secondly, some of the smart cities that we are talking about are going to be probably much more easily done if you're going to start with from the beginning. For example, if Chandrababu Naidu is wanting to build Amravati as the capital of Andhra Pradesh, it's going to be much more easier than modifying Hyderabad per se. Look at the way Chandigarh was developed. Chandigarh is one of the most planned cities in this country, and that was made possible because of the French architects who designed it that way. So one is modification, second is creating from the scratch. And both are possible, but one of them has a limitation, namely modifying the existing cities and creating new smart cities. The role of civil engineering is going to be enormous, if you will.
Thank you, TSK. I really like that explanation because I personally have felt that civil engineering is growing by the day, by the hour, with the emergence of new technologies that are connecting infrastructures, services and products and people together in the connected universe concept. And coming back to the multidisciplinary aspect of teaching and learning, how would you describe the curriculum at MEC from this multidisciplinary perspective?
Okay, just to simply say it, because most of the young people would understand, it's just different. Like one of the advertisements says that for Maggie sauce, wow, what is Maggie sauce? It is simply described as it's different. Similarly, the course structure at MEC is very, very different. If you really want to address any engineering problem, there are two elements which are absolutely essential. One of them is physics and the other one is mathematics. These two streams become absolutely important to address most of the engineering problems. There are engineering problems which may have very little component of these two. For example, if you're going to think about biomedical engineering, probably the applications of these things could be lesser than what it would be in other systems, but then they would also involve a significant amount of mathematics and physics. Physics becomes absolutely essential because you need to understand how the systems function. What are the basic governing laws? Which are the principles that you should apply in order to make the systems work? And the mathematics become absolutely mandatory stuff in order to model the physical system in an approximate fashion and be able to solve it. Therefore, mathematics and physics form a significant portion of our curriculum. In fact, if you look at Mahindra Equal Central's curriculum, we do not necessarily have departments, but we have four schools. One is a school of natural sciences, which will involve mathematics, physics, and chemistry, biology. These things are one portion which is called the School of Natural Sciences. Then the School of Engineering Sciences, which would address various aspects of engineering, be it mechanical, be it civil, be it computer, be it electronics or electrical. And then the third one is School of Humanities and Social Sciences. After all, these engineering products or the engineering principles need to be applied to the society that we live in or the societies that our people might probably migrate to. And therefore, you need to understand the human needs and the social needs. And therefore, the third school of humanities and social sciences. And then the fourth one that we have is School of Creative Sciences. Everybody keeps on talking innovation, innovation these days. It's probably one of the words which is uttered many a times without really understanding what innovation is all about. And that is something which is addressed in a very, very different manner at Mahindra Eco Central. And therefore, we really look at it this way. School of Natural Sciences, School of Engineering Sciences, School of Human and Social Sciences, and School of Creative Sciences. Putting all these things together, we are wanting to create people who are leaders, entrepreneurs, and innovators. The innovation aspect comes from the creative sciences. Entrepreneurship really comes from School of Human Sciences and Social Sciences, and the leader is with respect to any field that they may choose to really work in. And therefore, our focus has been creating just not another prototype engineer, if you will, but create a leader, entrepreneur, and innovator by combining the natural sciences, engineering sciences, human and social sciences, along with a fair amount of infusion of creative sciences in the student's mind.
Thank you, TSK, for that very nice description. It actually takes us to that word, the phrase that we've been using, the rise of the new engineer at MEC. So how would you define the new engineer?
The new engineer has to look at multiple things probably which was not a serious concern maybe a few decades back. Today the products or the solutions need to be sustainable. That means you need to take care of the product and the society along with that. Today we are worried about the environment. Today we are worried about the pollution. Today we are worried about what kind of world we would leave to our posterities. And therefore, the rise of a new engineer is of a very, very different kind, who is not only looking at what the societal needs today are, but then whatever that you create today, how is it going to be sustainable over a long period of time and not pollute or damage the environment that we live in. The pollution could come from probably in the air, or it can come from, it can get into the water that we use, many aspects. Honestly speaking, everybody is worried about the amount of oil that the world has. Much more serious commodity is water, which we tend to take it for granted these days. Everybody, every house leaves the tap either not closed properly or leave large amount of water to drain. And water is going to be much more expensive in another 50 years than oil. The requirements, one can probably manage to live without oil, but then imagine the life leading a life without water. It's almost impossible. This is what the new engineer needs to look at. How these solutions are going to be sustainable, how we are going to put this into effect to see that our future generation is not going to be deprived of whatever little that we have today.
Thank you, TSK. And coming back to MEC and the faculty at MEC, It's been a matter of great pride for us at MEC that our faculty are from a very broad spectrum, both geographically, experience-wise, and academically. Would you like to say a few words about our faculty and also the structural hierarchy in the institution?
Before I start talking about the kind of faculty that we have at MEC, uh, but in a broader sense, let me tell you that uh, the people who don't get anything suitable after their BA degree tend to do their masters, and those who do not do well or do not get anything after ME tend to become the faculty in their own schools that they have studied. It is unfortunately the kind of situation in most of the schools in the country that we have today. So what happens is that those who teach are the ones who have gone through the system and have not had kind of exposure that is needed to impart the right kind of experience to the students. Unfortunately, this is the case with many institutions across the country. Whereas at MEC, Mahindra Equal Central, those who are passionate about teaching, those who have had enormous amount of experience in the industry, those who have had enough amount of experience in research, have taken up teaching as their career. This makes a world of difference. They are able to bring in the right kind of perspective and tell the students as to what is it that they should look for and what is the need of the industry, how does the industry want to solve a problem, and how it can be made sustainable. And these are the aspects that many faculty that we have are able to address in a very a simple manner, and our students are absolutely enjoying the kind of pedagogy that we have at MEC. This is a very essential ingredient for a good school in order to have the right kind of engineers churned out for the future.
And TSK, what about the other deans, the other heads of departments at MEC?
Again, okay. There are no departments. This is something that I have told you. We do
Schools.
not want to, having said that everybody is creating a watertight compartment, and that shouldn't be the case. We did not want to have departments per se within our school. Our school has four broad schools: School of Natural Sciences, School of Creative Sciences, School of Human and Social Sciences, and School of Engineering Sciences. And we have people in all these four streams, four aspects of one's study, and people interact in a manner by which the right type of education is imparted to students. And the students become either much more mechanical oriented or computer science oriented or civil engineering oriented or electrical engineering oriented, depending on the subjects that they tend to pick. Unlike all other schools across the country, we have a first 2 year of common curriculum, and from the third year onwards, while there are certain specific departmental, so-called quote-unquote departmental related courses, for them to appreciate what happens in the rest of the areas of engineering, the rest of the courses are chosen by the students like the way they do in the United States or some of the developed countries. They do a major and they do a minor. If you take more number of courses in mechanical engineering related aspects, you tend to become a mechanical engineer. And if you take more subjects towards computer science engineering, and that students finally will become a computer science engineer, if you will. And this is how we are structured. There are no specific departments, but there are four basic schools, and these schools are combined together in imparting education to the students, and the students get aligned to a particular stream based on the number of courses that they would take in terms of mechanical, civil, electrical, or whatever it is. For example, uh, we have courses which are in the mechanical department. Somebody who is having a major in computer science may want to learn more about it, and he can opt for that course there. These are courses like mechatronics or your control algorithms, etc., etc., which could be a portion in the computer science, but then the course could be offered in the mechanical engineering department, and therefore they take the appropriate electives and come out with some major aspects of their course and some minor aspects of this course.
Thanks, TSK. And at MEC, it's a known fact that we are trying to answer or respond to the industry expectations in engineering. And towards this end, how do you think the selection of faculty members has happened?
Okay. The alignment to the industry is absolutely essential because they are the consumers of the schools or the colleges or the universities. If the university or the academia is going to be mutually exclusive with respect to the industry and don't really look at the needs of the industry, the engineers that the schools or the universities or the colleges that they create are not going to be so easily employable. There is a misconception that has come about in the last decade or so because of the IT sector. Irrespective of the course that you may do, they take the people in and train people in a particular language or a particular database and deploy them anywhere. That's slowly coming down. The society or the consumers or the customers are looking for specific skill sets, and therefore you need to understand, be able to appreciate the varieties of things that are happening in the various fields, and be able to address the multidisciplinary approach of solving a problem, then saying that, no, I don't know, this is not a mechanical engineering problem, and therefore I wouldn't be able to say. But that's not what we expect, and that's not what we train our students for. And therefore, the kind of engineers that we create are multidisciplinary, and they would be able to look at the problems of the industry in a much better sense. It's not only that. The kind of course structure that we have is much more hands-on, and we will also have professors from the industry or the experienced personnel from the industry come and teach at the institute. And they would be able to talk about their current problems, current pain points, and then they say that how they are trying to attempt it, how they are sometimes able to do it, and how they are unable to do it on many, many occasions. If these problems are known to the institution or to the students right at the beginning stages, probably many heads can think together and arrive at a particular solution. This cannot happen if you keep the industry far away from the education. And bulk of the universities have written down their syllabus and their curriculum and published it, and they have remained static for centuries together, 50 years, 70 years, 100 years. The curriculum has not changed at all. Whatever is the need of the society, they create a new course. A new course is absolutely not needed. A new way of looking at things is more important than adding a new course. If you really look at the number of courses in AICTE, there are 632 courses. There is no need for 632 courses. Somebody calls it as electronics and communication engineering. Somebody calls it as electronics and communication technology, somebody calls it electrical and electronics, somebody calls it as electronics and instrumentation, somebody calls it as instrumentation, and all these things are finally the basic stuff remains the same. Instead of addressing the delta pieces, the additional information, and package them into the course that they are studying, they are creating new courses, and these courses there are many people who cannot teach, and that is where we are trying to see the people from the industry come into the curriculum and teach, and we don't want to keep our curriculum a static one. Our curriculum, what exists today, will change as per the needs of the industry. Without which, if you're going to have a book which says that this is the course and this is what we shall do, that's not a right approach to engineering, and that's not going to really create the kind of a rise of the new engineer that we talked about. It is going to be the rise of the old engineer only. Never ever will it be new engineer, because you're following a curriculum which was designed some several decades ago.
Yeah, so in a way, it's a revival and a strengthening of the old school, with a new direction and responding to the newer needs of the society and industry. I got
Absolutely,
that.
absolutely.
Thanks. And from inception, TSK, MEC has been striving to establish industry academia connects through various means and through various ways. Could you talk about a few instances where MEC has actually connected with industry, enabled certain networkings and meetings so that the students and the faculty members and also our external stakeholders could benefit from it?
Absolutely. I'm sure this is there in our website already. A couple of weeks back, Dr. Payne from the UK came and delivered a lecture called Google to Glass, and is internationally known expert in the area of communication. He is from Southampton, United Kingdom, and he spent a complete day with our faculty and also addressed a larger gathering of students as to what they should be looking at and how they should be looking at. And we had Professor Vidya Sagar, who was the director of the erstwhile CARE, Center for Artificial Intelligence and Robotics, which doesn't exist in that form or shape today. It is called something else. He was here addressing how the medicinal applications that can be done in an effective manner through mathematical modeling. As a few weeks back, a gentleman from an outstanding scientist from ISRO who came and talked about what is a scientific temper and how important it is for engineers. And there are many such lectures that happen beyond the classroom and by the experts. And this would open up the thinking or the kind of mindset that the people have and look at the problems in a very, very interesting manner. In addition, most of the schools create a kind of industry connect or pre-placement discussions, etc., with some industries, and industries coming and talking to them when the students are in their 4th year of engineering. And we said that it's not going to be, we are not going to be waiting that far. After the courses are begun, in the 7th week of its inception, our first year students, first semester students, who are after +2 into the engineering college, just after 7 weeks, they had an interaction with the industry from France and also from India. It was an industry academia connection which happened on the, I think, 19th September 2014, and the school just began in the month of August 4th. So within 7 weeks, they got to see how the industry, what the industry needs are, and how the industry is willing to talk to MEC, and perhaps over a period of time, look for interns from MEC to go and work for them. So this becomes absolutely essential. Not only that, uh, on the 13th of April, that's about 2 days from today, we are going to have a Indo-French workshop on various aspects of research that need to be conducted. This is sponsored by the Indo-French Coordination for Promotion of Advanced Research. The two governments are getting together, and there is a government institution, and they are wanting to conduct this kind of workshop with MEC at MEC, and this is going to throw open a large amount of interaction with the faculty and also the kind of research that they would do, and that would probably percolate to students looking at the newer problems the industry is looking at. And thirdly, we also have an industrial liaison person who is talking to many industries and look for opportunities for internships for all our students. We are connected with Mahindra, and many people will definitely get an opportunity to intern at Mahindra. But then Mahindra is not going to be the only company who take our students for internship. We are looking at many industries to come and look for internships. For example, the interest was evinced by IBM. The interest was evinced by National Instruments. The interest was evinced by Tektronix. The interest was evinced by Tata Consultancy Services. The interest was evinced by Thales. The interest was evinced by Airbus and also by Safran. This kind of a connect doesn't happen without the kind of work that goes behind. So we are not simply stating that we are going to be an industry-oriented university. We are very seriously connecting the industry with the academia.
Thank you, TSK. And you've spent a long time at Tech Mahindra also in one of your earlier avatars, if I remember rightly. And we all know that Tech Mahindra is an IT and enterprise solution company that has more than 350 customers across the globe. How would you look at this scenario from MEC perspective?
Definitely, the opportunity for computer science students would span across a larger number of customers that you had mentioned. But the non-computer science candidates definitely can align with the engineering group within Tech Mahindra, which is one of the strongest groups, and they address problems in the mechanical, civil, and electrical industries. And if you really look at the four streams or the four majors that people would be majoring into are mechanical, electrical, civil, and computer science. And combining ourselves with the customer base that Tech Mahindra has, we will be able to almost cover all our people with the right kind of customer connects. And secondly, like our founder director said, we do not believe in this kind of arranged marriage. Mahindra is our sponsor for the institution, if you will, and we do not want to get hooked on only to Mahindra. Mahindra will also be one of the companies that would look for our students as interns. Like our founder director said, that we want our students to date with many industries and choose something of their interest, then simply aligning themselves only to Mahindra. And therefore, we are looking at a space which is much larger than Mahindra, while Mahindra is also an important element in the overall game.
And TSK, a lot of industry heads and CXOs and CIOs have visited MEC campus over the past few months. What has been the reaction to this newly set up institution?
Bulk of them have said that, wow. They have visited many schools in connection with getting the right kind of skills, uh, but whatever that they got to see here, they were simply amazed. And they looked at the curriculum, they interacted with the faculty, and then they looked at the kind of infrastructure that we have created. It is absolutely, truly world class. Some of them even said that, oh, this is almost like an Ivy League school. The Ivy League schools are on the eastern coast, like Massachusetts and all this kind of schools there, Harvard, Massachusetts, and the good schools, Yale, Carnegie Mellon, and all those things. Uh, they are saying that the school is no less. It is as good as that with respect to the infrastructure, with respect to the research possibilities, with respect to the faculty profile. They were simply wowed by whatever they got to see.
Thanks, TSK. And I'll come to one question that often keeps coming up from parents mostly. They ask about what kind of pay scale will my child get once he graduates from MEC. Is Mahindra going to give them that kind of pay scale, or is it going to be one of your foreign collaborations? Will they be working in France or India? These are the typical two interrelated questions that keep cropping up. For the benefit of the viewers who may have a similar question in mind, would you be able to respond to that query?
I do not want to be directly saying this, but then uh, we are not here for bargaining for salaries or nice placements. If you're good, your salaries are not going to be limited at all. Like the way it's so painful that assume that you are putting your child in ISB or any of the IIMs or IITs. No parent would ever ask this question. I understand that the people are nervous and they want the return on investment at an individual level, which is understandable, and I appreciate that. But then, like the way that we are wanting to contribute to society, we want them to look at creation of the kind of infrastructure, the creation of the kind of products, the rise of the new engineer, and the money will automatically follow. I'm not saying that money is not important. Money is absolutely important. But then you're not here trading, saying that if I do that, I will get that. Have faith and be good, be smart, understand, contribute. Money is not going to be a limitation at all. Money is not going to be a limitation at all. Somewhere from University of Hyderabad, somewhere, one of the students has got offer with Google. How many people can get that kind of an offer? Several hundreds of thousands of rupees in rupee terms. In dollar terms, it is very, very close to about almost like $0.7 million is what his salary was. How many students of University of Hyderabad get that? He proved himself that he is worth it. Similarly, if our students are going to create that kind of an indelible impression in the minds of the customers, forget Mahindra, anybody for that matter, salary is not going to be a concern. And it is unfortunate that we relate education to salaries and employment. It is necessary, I'm not saying no, but it is painful. If you're good, you will get a salary is not going to be limited at all. It's going to be very good. But having said all that, what is the kind of salary that one could expect? I cannot simply wish away this question by answering in a generic fashion. The salary could be to the tune of 5 to 6 lakhs. Would be the kind of money that they will be able to get per annum.
Thanks, TSK, for having really and truly answered that question finally. And talking about MEC creating the right kind of environment for students, hardworking students, to prove themselves. What's your take on how our case study based and project based and internship based approach to education is being rolled out? That's being rolled out right now.
Let me get the question right.
Yeah, talking about creating the right kind of an environment for the students to excel and prove themselves and get good jobs with good pay packages. What's your opinion or your take on the current case study based and project and internship based approach to education at MEC?
Okay. See, if you go to the management school, the entire study is case study based. But if you come to engineering, bulk of the engineering schools go by the kind of courses that they study or the areas in which they do the major or minor. The way that we will distinguish ourselves or differentiate ourselves is that in addition to the major that one might choose, the kind of education that is being imparted to them is much more hands-on than just being theoretical. Some of the labs that we have, probably people should pay a visit to Mahindra Eco Central to believe that kind of a lab exists in an undergraduate school. This is something awesome, phenomenal. And we believe that engineering cannot be studied only in the classroom. Engineering has to happen outside the classroom too in terms of practical experiences. It's like one of my dear friends who has studied internal combustion engine, etc., and he is a PhD in that. But when his scooter's car stopped on the way, he does not know where to look for the spark plug. He couldn't even start a scooter. Whereas solving that internal combustion equation through fourth order differential equation through Runge Kutta, he was at ease. But when the scooter stopped, he didn't even know where the spark plug was. So it's not that kind of engineer that we want to create. Look at it this way. You go to a hospital. There is an operator who operates that CAT scan machine. Right? He gets to operate the most costliest equipment in the hospital. That doesn't make him great. He can create only the scan. A doctor has to see that and diagnose it. So we are wanting to create that kind of doctors than this kind of CAT scan operators. Unfortunately, in most of the schools that we have around the country, we are creating more and more operators, not the doctors. And that is exactly what we want to avoid by making our people not only read the theoretical aspects or the theory behind it, for which we are providing solid background in mathematics and physics, but then expose them in the laboratories where they build and break and understand things in a much better sense. It's not only that. I told you that while the management study is much more case study based, here it is much more project based. For example, in the second semester, the current semester that's going on, we have groups of people who are making process industry based films. They go to an industry, understand as to how they do and how the processes can be improved or what is the current level of maturity of these processes. And this kind of project-based experience, what happens is that when they work as a group, they start to understand the group dynamics. Engineering, unlike medicine, a single doctor operates, a cardiac surgeon operates. An engineer or a product is being created by a group of engineers. And therefore the group dynamics becomes much more important, and therefore this kind of process oriented documentary making really is helping students to work together to understand the nuances and be able to create something substantial out of whatever that they are learning. And thirdly, as a part of their internship, it is not that they go to an industry, spend some 8 weeks time and then come back and get some stupid certificate saying that they have interned in a particular location. Most of the companies do not want interns because they have to waste their time with the interns. Our interns are not going to be like that. They are sought, or they will be sought after by industry, and they will be working along with the engineers in the industry and try to look at the problem and contribute solutions to those things thereof. In addition, we also have courses purely based on lab. That course is no theory. If there are 10 to 12 experiments that are available in a particular area, they would take up a lab course, and the entire semester they have to build an equipment and measure something that they intended to measure, and compare that with the theoretical solution which they have studied, and create a mathematical model out of that. This is an experiential learning. However great computer that you may have, however excellently that one may end up modeling the physical system, when you model it and test it, there is always a difference between the theoretical based estimate versus whatever that is measured. And these people have to understand why there is a difference. What is the kind of difference that is acceptable? And if there is a difference, how do we adjust this? For example, tomorrow you are going to be employed in the Indian Space Research Organization, and you are launching a spacecraft. Now you want to know in the space, how would it behave when you change some parameter? Can you do it on the ground? No, you have already shot it in the space. You've got to understand, and therefore there is a mathematically correlated model with respect to the test results is a mandatory thing. You know that this is the model that you have built, this is the result it gives, and you have tested it. This is the object that you have tested it, this is the result, and the results are not matching. Now, what could be the errors in these two? There could be errors in the mathematical model, there could be errors in the physical test. None of them is error-free. How do we understand these errors? How do we factor in these errors? And therefore, the theoretical model and the mathematical model and then the experimental results, all the three will match. If you have such a model can be used to predict what could happen to the spacecraft in the orbit when you make certain changes, because you know that this is a correlated model. And this kind of experiments, pure experiment is one course, 3 credits that they would do towards their third year or whatever it is. So that's another. See, one is case study based, which is management. Here it is the group dynamics based, then internship in the factory, and then building an experiment and testing it with the theory. With all these things, the kind of engineer that we would be creating is going to be rather a practical person who would be able to understand not only that particular major that he has been working on, but also the surroundings around him. So we develop a concept of the core and adjacencies. Unlike many other places, they focus just on the core. We create the core and adjacencies. We make them understand to work in a group. We make them understand to work in the factory. We make them understand to build and correlate things. This is how the entire course is going to be designed and managed, and that would make them a real quote unquote new engineer of tomorrow.
Thank you for a very insightful explanation of that, TSK. Now I have something purely from the academic perspective. We have had quite a few questions over the past from parents and students asking about the academic structuring at MEC. They see the Mahindra group name in the name, they see Ecole Centrale, then they read about JNTU on our prospectus and website, and a lot of them have sought clarity on this nexus or this collaboration. Could you talk a little bit about this collaboration between these three universities?
Sure. Bulk of the education in India is based on the Anglo-Saxon model, which all people are very much used to. You do your 10th standard, then do your +2, then write engineering entrance examination, join some institution, do a common course in the first year, then you branch off into the department and do that particular department related courses, etc., etc., come out. This is a normal Anglo-Saxon model. The model that we have is essentially not the Anglo-Saxon model, it is an European model, where there is a significant emphasis on the natural sciences, and there is a significant emphasis on multidisciplinary aspect of engineering, and there is a significant emphasis on innovation. So all these three things have been combined, and this pedagogy essentially comes from the European model. And Ecole Centrale Paris, now called Centrale Supélec, is one such school which was established several hundreds of years ago, 200 years ago, by Napoleon. And they have created phenomenal amount of successful engineers who are very, very practical. Gustav Eiffel, the man who built the Eiffel Tower, is Ecole alumni. And then Pierre Michelin, the tires, he is again Ecole alumni. Renault, he is again Ecole alumni. So this kind of successful engineers who are not only just pure engineers, entrepreneurs, leaders, and innovators have been created by such an amount of education. So we have drawn up this European model from Centrale Supélec or the Ecole Centrale, right? And while we have taken the content, the style from them, we need an infrastructure that can administer that kind of education to students. And that's where Tech Mahindra came into picture. Tech Mahindra has created Mahindra educational institutions, of which Mahindra Ecole Centrale is a college, where the pedagogy from Ecole Centrale or Centrale Supélec is taken in. Tech Mahindra has created the infrastructure, and we are a college, we are not a university, and therefore we cannot offer degrees. And we have gone ahead and explained the whole process to JNTU, Jawaharlal Nehru Technical University at Hyderabad, and they were absolutely zapped with the kind of program that we have, and they gave their blessings, and they said that you will have the academic autonomy, if you will, and then they were very, very pleased to have Mahindra Ecole Centrale as one of their colleges for the students of which they will award the degree. So JNTU Hyderabad will award the degree. Tech Mahindra has created the infrastructure, and Centrale Supélec or Ecole Centrale has given the pedagogy. So this is the combination of the Trimurtis, if you will, Brahma, Vishnu, and Shiva. And they have created this entity called Mahindra Ecole Centrale.
Thank you, dear TSK. That was a very wonderful summing up of the basic academic structure at MEC involving all our stakeholders. And that also brings us to the end of questions for today. And I'm sure we'll have more questions pouring in over the next few weeks for our other Hangout sessions. We will look forward to having you with us again in the future, and with much more interesting tales to tell and a lot more insights to share with us, like you have done today. Thank you for your time today, Professor. And I wish all our viewers a very good weekend as well. And I request them to keep logged in, tuned in to our future Hangout broadcasts. And with that, this is Praveen Raj Gulapalli signing off. Thank you.
Thank you. Have a great day.
Thank you, sir.